Welcome to our video 2. This one we will start with chapter 2. We will start with chapter 2 in our book. So let me go to the book. Now, Introduction to Electrical Systems. Introduction to Electrical Systems. Let me just go straight to now. Here, the chapter is telling you that it's distinguishing between the scientists and the engineers. The scientists will seek to explain the mysteries of electric system, but the engineers will seek to make use of it. That's our own concern. In fact, electrical engineering could be summarized into 4 categories: production of electrical energy, transmission of electrical energy, the application of electrical energy, the control of electrical energy. Now, an electrical system has 4 basic parts. We have the source, which is the origin, where the energy comes from. That is where energy is produced. We have the load, which is the consumer, the device that consumes electricity. We have the transmission system. The energy has to be transmitted from the source where it is produced to the place where it is going to be used by the load. Then we have the control apparatus. Electricity can be dangerous, so it has to be controlled. So we need some control apparatus. Now, wherever you are, please help me look at your room. Give me an example of source. It may not be, you may not have a source there. The source of electricity, if it is NEPA or PHCN, the source is Kainji and some other power generating stations. If in your house, if you have a better pass my neighbor generator, then that is a source. Look into your room again. Perhaps you have fan in that room, that's a load. Perhaps you have bulb in that room, that's a load. Perhaps you have a radio set, a TV set, a computer. All these are what? They are loads. And you have the charger to your phone. The charger to your phone is also a load. Your phone is also a load. Transmission system, please look at your room again. You may see some wires. That wire is the transmission system. On your street, you see wires conveying electricity from the production to distribution and to consumers. And look at your room again. You may have some control apparatus. You may have the switches in your room. That's a control apparatus. You may have a fan regulator. That's a control apparatus. You may have some remote control for your TV. That remote control is also a control apparatus, because with that remote control, you can tell your TV what to do. So, now this figure 2.2 is a layman diagram. It's a photo showing your generator, a pair of wires, your switch, and your bulb. We don't like this type of diagram. This is not an electrical engineering diagram. We prefer figure 2.3, where it is symbolic. The G means a generator. And then you have the symbol for the lamp, then the symbol for the switch, and then a line is a wire. It's a symbol for wire. We prefer to speak with symbols. We speak with symbols. You can have a table there, wire, generator, bulb, switch. As you go along, you are going to learn more symbols. We have what we call the electric charge. You have what we call electric charge. Go back to your chemistry. You are told that an atom is the smallest indivisible particle of an atom. Don't mind that. They have started destroying atoms. But in the atom, we have the nucleus, which contains protons and neutrons. Protons are positively charged, neutrons are neutral, and then you have electrons, which are negatively charged, rotating round the nucleus. So that's the beginning of electricity. Because the electrons are not moving, that's static electricity. When the charge moves, we have current electricity. Movement of electrons is what we call electricity. And then please read more of that. I cannot be reading for you. As students, you have to read. So when you go to current flow in a circuit, we are told that there must be a complete circuit around which the electrons may move. There must be a driving influence to cause the continuous flow. This influence is provided by the source, which causes the current to live at a high potential and to move around the circuit. So we need a driving force. I don't know if I see this particular video and this particular image. Do I have it here? Yes, I have it here. Let me open it. Open with that. Yeah, this is showing you the current. The current ampere is this animal, which is trying to move. This resistance is an opposition. You can see that is a wicked person. He's trying to tie the rope on that passage so that the current will not be able to move. We need some force, which is volt, to push it against the obstacle. So the volt is like your EMF or voltage that will help you to push the current against the opposition. Please remind me to share this photo with you, or I think you are even seeing it like this. You are seeing it in the video like this. I normally share it in class like that. Thank you. Let me return back to our book. So you need electromotive force. You need what? Electromotive force. That electromotive force is to help us force against the obstacle so that the currents can move. The charges, when we say current, it is the charges that are moving. You can see that the charges are sweating because they are going through hard time, through difficulty. Now, so we need electromotive force and potential difference to ensure the movement. So this circuit, you can see the EMF is the one driving the current. And across the load, we are going to have what we call potential difference. General symbol for DC. If we have DC, this is what we are going to have. Electrical unit. We have the current. The current is measured in ampere. Read more about that. We have the quantity of electricity. That is charge. Actually, charge equals current times time. Or current equals charge divided by time. Charge is measured in coulomb. You should get used to that. Giving an example there, if 25 coulomb passes a given point in a circuit in a time of 125 milliseconds, determine the current in the circuit. Please, you have been given the charge, you have been given the current. Too simple, you can do it on your own. Potential difference. That's a volt. I'm going to explain the potential difference to you. When you have current, there will be power. Power is given as P over I. Voltage is given as P over I. Power is given as VI. And this equation. So you should remember these equations. Please take example 2.2 on your own. You are given certain things and you have to find things. Resistance. Resistance is measured in ohm. There is this equation that is known as Ohm's law. By Ohm's law, if we have resistance and current is passing, there will be a voltage drop. There will be a voltage drop across the resistor. Across the resistor. That voltage drop is V. We consider it such that this end will be positive, this end will be negative. The end through which the current is coming is considered positive. And then Ohm's law. Ohm's law, you have come across it in your physics O level. Ohm's law states that V is it a symbol for proportional? Or I should close it. That symbol is proportional to current. And when we say proportional, there will be a constant of proportionality. So we write that V equals Ri. Where R is the constant resistance. It is the opposition to the flow of current. So you should always remember this. Now let me return back to our book. Now, we have resistance. Power is going to be equal to IV. Since V equals I half, power is going to be equal to I square R. Please let me take the examples on your own. Example 2.3, electromotive force. The electromotive force has to do with battery. The principal sources of EMF are as follows. In your battery, if you have electrodes in the battery, there will be EMF. They call them cells, they call them battery. In generators too, you can have EMF. Also, difference of temperature between junctions of dissimilar metals. They call them thermal junctions, can also generate EMF. You can generate EMF in several ways. This Ohm's law, I've mentioned it. Please read it. Thank you very much. Let me go ahead. These equations, you have come across them. Example 2.4. Please work it. It's saying that a motor gives an output power of 20 kilowatts and operates with an efficiency of 80%. If the constant input voltage to the motor is 200 volts, what is the constant supply current? The output power is what? The output power is 20 kilowatts. And then we have the efficiency, so we can know what power goes in. If the efficiency is 0.8, it means the input power is actually 25 kilo. And then set that equal to VI. They say the motor has 80% efficiency. They say that you are giving the output power. So you need to find the input power. Efficiency is input power over is output power over input power. So our power in will be PO over efficiency. So you are giving the output power so you can calculate the input power. Once you get the input power, you are giving the voltage, you can get your current. As simple as ABC. Please, example 2.5, done. Again, when I say done, you know what it means? Go and do it. You can do it. Then we have symbol. We communicate with symbol in engineering. That's the symbol of a fixed resistor. This is an old symbol of resistor. This is a variable resistor. That means the values can change. It is also known as rheostat. This is a potentiometer. It's also a varying resistance. It's also a varying resistor. You are to read. So let's stop this video here. This is the end of our video 2. Thank you very much. Oh, thanks for listening. Thanks for